So that's how the short circuiting works. So whenever you have multiple values, it doesn't mean that all conditions will be checked. So if there is an OR, it will try to check for the first valid condition, which is true. Whereas if you say AND, it will check till the last one also. Next, in the same fashion, we will go for the next thing called as Boolean operations. So in the Boolean, if you see, it's very interesting to work with the Booleans. I believe that Boolean is the heart of not just Python, any programming language. So why I'm saying like this, Boolean is the heart. In most of the languages, this will not be told to you. That would be a backend process. But in languages like Python, it is a bit easy for us to understand what's happening. Till now, what you understood is that whether you go for the relational operation or logical operation, you get the result as true or false. That is Boolean. So Boolean is like this. Now, Boolean will tell multiple things for us. First, I told you about the ID, right? Address location where it is stored. If I assign like two variables, like choice equal to true and choice equal to false. Now see here, it will tell which address location where it is stored. If I need to go back ls to the 03 Boolean operations, now clear and Python a so and so. So first one is true. It's a Boolean. It is in an address location. Now let me execute the same thing again and again, show you something. Python a so and so. Did you see? Did you observe that these address locations are changing? You know, true is a built-in object. So built-in object means the moment you are starting Python, mean running, so these will be ready-madely executed. But even for the built-in objects and the keywords, the address location is changing, right? Means it is not fixed anytime. Even at least in the immediate executions also, you see the same thing. So that's what I want to tell as another thing. Next, I told you already that keywords, so true is a keyword, right? You should not use like an ordinary variable. If you try to assign a value to it, it will throw in error. Earlier in Python 2, it used to do, but in Python 3, they did not allow it. So, and similarly, if you want to execute, you can write a other implementation, small true, or you change the case sensitivity a bit and you can work. But that is not recommended. They say that if you really want to use, why can't you use another thing? So instead of true, I can say like, true name is equal to give the same thing, Uday, but true name you make. So if I make the true name, the same thing will come, but with a slight difference, right? If I say true name, I'm asking the value, type, and address location. So this is what we did till now, clear and so and so. We got like true name, value, address location. You see, the address will change every time, that's for sure. So then we get the other values. If I go further, you can see that, as I told you till now, that Python is an object-oriented programming language. It will have a standard way of doing. So every object will have an address location. But what you can observe is like, for the built-in objects, the address location is slightly different compared to what we have here, right? The address location of both are very much different. Their locations and others. If you see, yeah, this is somewhere in the way different, and this address location is a very different thing. If I define like one more variable, say, not just thing, I define the same choice itself with the same name, I can overwrite, right? I am defining one more variable and I'm asking. If you observe carefully, so this address location is different, right? So these address locations and these address locations are very different. So that is what I want to bring to your another notice. And lastly, so one more thing I want to tell you is that, sure, ID is a built-in function for getting the address locations. So you can check like this also. For an ordinary variable and this custom variable, things were different. And the most important thing about the thing, when I'm learning, I learned one interesting thing. For true, if you multiply with anything, you get the same value. What do you mean by that? There is something, and if for that, if you are multiplying with anything, you get the same answer. Then don't you think that true is having a value of 1 in the backend? Similarly, false. If you multiply with anything, you get the result as false. So it means 0. What do you mean? So if I take this example, fine. If I take like one more example, say like, same thing, 3.4, and I multiply with the same thing, 3.4. If you observe, you will notice that you get 0, either 0 as a float or 0 as an integer, but 0 only. So which he understood that 0 has a value, so of 0 in, sorry, false has a value of 0 in the backend, and true has a value of, so positive 1 in the backend. If I go further, you can notice that. So for the booleans, so as I told you just now that it is having a value of 1 or 0 in the backend, I'm making a comparison and I'm asking, hey, do you have 1 as a value in the backend? I'm just asking. Yes. Are you having a value of 1? Yes. Are you having a value of 3? False. Are you not having a value of 3? Yes. So similarly, I can ask the same thing here for the falses. Hey, so do you have a value of false equal to 0? Yes. Similarly, I can test batch the same things. True is equivalent to 1.0, false is equivalent to 0.0, and true is equivalent to 1.1. So when true equal to 1.0, yes, means 1 or 1.0 means integer or float, both it can compare. Means you can compare 1 is equal to 1.0, both are true. So 1 is equal to 1, that is also true, because both are of same family, right? I told int, long, float, all this boolean, complex, all these things are same family. So it works like this. Now, sir, one last point. So can I check 1 equivalent to 1 plus say 1j? Can I do like that? No. Yes, both are of same family. It doesn't mean that so both are equal, right? So this is one exception. Next, if I clear screen and execute again, you get it. Fine. Next. Okay. Now, one very, very interesting question comes to picture. You told that, so with this bit is clear, 0 has a value of 1. Sorry, true has a value of 1. False has a value of 0. Now, I want to do some very interesting question. This is one of the interview questions you got. If I go for the IPython environment, if I clear the screen, so you know that 1 is equivalent to 1. So 1 is equivalent to true. That is also clear. Now, if I say str of 1 is equivalent to str of true, I'll do. As both are equal, if you place both in two separate bags, both should be same thing, right? But it doesn't work like that. Why, sir? If I say str of 1, what I'll get? 1 as a string. But if I say str of true, this is very interesting. Instead of 1 as a true, you'll get true as a true. Sir, what is this magic? Magic is that true acts as a 1 and a false acts as a 0 only during the arithmetic relation logical operations only. Means whenever you're doing addition or comparisons, conditions, that's where only it will convert like it's 0 or a 1. In other cases, it will be as it is. That's the reason, though they are equal, their string conversions are not equal. Similarly, if I convert str of 0 is not equal to str of false. This is one of the very, very important point you need to be remembering. Then one more interesting point. So then what about this one, sir? Does this work? So you told that when you convert to any other operation, it doesn't work. But if you are doing arithmetic operations, multiplication plus all these things are arithmetic operations, then it will be true. Sir, how it is happening? If I say true, first it is happening like this. True into 1 if I do, as it is an arithmetic operation, it is converting to 1. If I do like an str for that, what will happen? It is a 1 finally. So that's why you got like 1 as a string. So many people don't know this. So we should be aware. And similarly, you do, I think almost all I told. But I told one thing, right? We cannot do arithmetic operations except multiply. You see, you cannot multiply true with a string. So true we can multiply with a 1. So true we cannot add with a string, right? That's what. But if you have two different data types, we can use the type converters. I told already the type converters, str, repr, int is a boolean, int is for integer, bool for boolean conversion. So this bool function, we will now go more into this bool function. What this bool function does, what we can learn from it. If you see here in the bool function, it's very interesting. So this is what I am telling till now about the heart of Python. So bool function works differently for different data types. So first, let's go for the case of integers. Let's go for the case of integers. When you have integers, for integers, or integers means int, float, so long, all these things. So long is not there in Python 3, but only in Python 2, just to let you know. Here and Python C so and so. If you see whether it is a positive or negative, it will be true. But if it is a 0, then it will be false. If I do the same thing for floating point values, again you can notice the same things. Did you notice that for the floating point values also, either it can be positive or negative, it will be okay, but it should not be equal to 0. 0.0000 anything is better than a 0, right? So that's why it will be true. Absolute 0 means that it will be false. Next, now here one condition for you. After, so this is an assignment. After decimal, if you write how many zeros followed by 1 in last will make the result as false. Okay. So this is what you need to do. Next, going further. Similarly, if I go for the next one, so you need to do that research and help me. So if I go to the strings, if I go for the strings, if it is any string, even a white space is also a string, right? If even for that also it will be true. But if you don't write anything, which is like an empty string, I repeat again, at least white space is one character. If you don't have any character, it's an empty string, length 0, then it will be false. If I do like a boolean, so a true or anything, you can see the differences. Let me show all the things here in one shot to you. If you see here, so for integers, non-zero is like true, 0 is false. Floating, the same thing, non-zero, true, 0, false. Strings, empty string, it is like empty strings, it will be a false. So for strings which have even one character, it will be true. Boolean none. None is a Boolean false. True and false are false. So same thing. True will be true, false will be false. But if you go to the braces, there can be different braces. I told there are three types of braces and values can be different ways. So what are these data types? I will tell afterwards. But if within the braces, if you have at least one character or one value, it will be true. If the braces are empty, then it will be false. So Boolean of braces, empty braces, it's a false. What is that doing? I will tell you afterwards. But if you see further, you'll notice that. You see, Boolean. So in relational operations, what we are doing till now, you dial like 73 greater than so and so. When you do like this, in the back end, it will pass to this bool function only and do. And execute and final result, it will pass. So that's the reason bool function, if you see any one code in professional language, they will not use bool function. So 98% of the time, you don't even use this bool function. But sir, why this function is there? So this function is there for usage in the Python code in the backend. So the people who write the Python code to run Python, right? They will use it. But this is for our to understand. Whatever the functions you write, what are the conditions you write, everything will go to this bool function only. So when you do like this, some condition, relational operation, so that will go to the Boolean only. But if it's the same way, if you go for like a logical operation, the same logic executes and the results again finally go to the Boolean. I told like Boolean of, if the end result within it is true, you get the true, false means false. So what I am trying to say is that in this way, you can at least understand what's happening in the backend. So in other languages, it is a bit difficult. And for any developer who is writing coding, learning coding, the basic thing is like the conditions. If you know how to write a better conditions, you are an expert. Half of the programming was done there. Similarly, one last thing. There is one more interesting thing called as this. So we have a module called as this. I want to introduce to this new module called as this. Sir, what is this module called as this? What it does? It's very simple. They created multiple modules. Then someone asked, what is your philosophy? Philosophy means like, what are your guiding principles? How do you do? What are your, not rules, but like, what are your philosophy about Python? So for that, they created something like a import this. This will does nothing. It will just give a static content. So no attributes, nothing. It will say that, beautiful is better than ugly. Explicit is better than implicit, like this. So it just tells like that. Wherever they are writing the code, they try to make the things like this. And one important thing is simple is better than complex. We can see like many people writing code, which is very complex, only they can understand. So that is not a good way. If you are writing a code, even a newbie should understand. So that is the beauty of writing. So because tomorrow after you're writing, there will be someone else to manage this, right? Sure. So now someone has written like some Boolean love poem like that with this. It's for fun. I'm just showing it. I'm assigning this value this to a love, and I'm comparing both the things. Did you see when you compare? When you do an assignment, both are equal, right? So when I'm doing like it, ID, address locations are also same. So address locations are also same because both are referring to the same object. Now they say that, so we can write different kinds of logics. Say, you see, so this is love is. So for the first time, you're using this new operator called as is. So what is this is operator does? This is another interesting thing. Before going there, let me show you something interesting. If I clear the screen, fine. Till now, you know that, say value 1 is equal to 123, value 2 is equal to 234. If I have like this, if I say value 1 is equal to value 2, it's false. You can compare the same 123 equal to 234. It says false. But if I say like value 3 is equal to say 123. Now if I say value 1 is equal to value 3, yes, it is true. It is same like 123 equal to 123. Now you understood this concept of equal. Now if I say value 1 is value 3, it's saying true. 123 is 123, I am writing. It is saying that for variables you can use is operator, but for pure numbers you should not use. So why, sir? I will tell you. When you do is, it will do an extra step. It will not only compare the values and their data types. Even if you know, if you see here, what it does when you compare like this, it is checking both the values and the data types, right? Fine. But if you are doing this is operator, it will check even the address locations also. So value 1, so value is like 123, value 2, value 3, value is 123. If you see address locations of it, as both were created in the same way, you can see the same thing. Value 1, you got it? And address of value 3, you get the same address because both are created from the same object, right? So both are created from the same object as you assigned here, right? I created with the same object, you got like that. But if you create with the different objects, it will be different. So for ordinary integers and others, you may not notice much difference, but subsequently you will notice is very different. And generally, so value 1, so is value 3, you understood, right? Generally, if you want to say no, means equal, not equal. In the same fashion, is, not is, right? So you want to write like this, right? This is what you expect, but it will throw an error. Generally, anything we need to prepend with a not, right? But what they did extra in Python is that they want to make it like English like language. So they did like instead of is, we should write is not. This is the most important point you need to remember as a beginner. You may feel it is a bit funny, but it works like this. So in Python, it works like that. So now you understood the importance of is operator. Is operator, importance. Fine, right? So this is how it works. There is nothing like not is, we have is not. Is and is not. So this is all about this operator. Next, the last point we go with is about the bitwise operations. So I never used in my career the bitwise operations, but so if you feel like you may be using, you can try it. But it's better to learn what happens in the bitwise operations, how they work. So in the bitwise operations to start with, if I go with like one program, so in bitwise operations, you do like bit by bit operations. Bit by bit operations means, you see here, binary operations you will do. Means for any numbers, if you do two numbers, if I say like 60 and 13, I will explain the logic how it is happening shortly. But if I take two numbers, okay, and if I need to get the binary numbers, if I have two numbers, like number 1 equal to 60, number 2 is 13. So if I want to get their binary numbers for here and Python, so A so and so. Did you see for 60, it is representing like this. For 13, it is representing like this. How it is happening? That is the magic. Let me clear this and explain you how it is working. So if you observe clearly, so first I'll try to convert these numbers and show. So when you have a 60, how it is converting? These are called as, binary numbers. Binary means like 2 bits. Generally, why this binary concept came means, So whatever the laptop you have, system, any electronic device, if within it, it will store like a flip-flop. If you remember what you learned in your graduation, the flip-flops and registers and all these things. So they don't have anything memory or anything. They will just store the presence or absence of a particular thing. So that is a binary. Binary means two conditions, right? So they will store something in that memory. If there is in a particular place, if there is a memory, it is true, else it is false. Or like 0, 1, like that they do. So anything when you are executing, finally we need to convert this Python code to the binary only to understand. So that's the concept of binary came. So with 2 bits, so it is like powers of 2. 2 to the power of 0 is 1, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, like that it will go on like that. If you have 60, how do you represent with 126? It is greater than 126 is greater. So you cannot represent 0. 64 is greater than 60. You cannot represent 0. 32 can we represent? Yes. From 60, if you remove 32, you get like what? Some 28. So can 16 we represent with 28? Yes. So after 16, you get like 28 means, so 8 and 4. So means like around some 12. So 12 can I represent with 8? Yes. So in 12, so if I remove 8, I get 4. I represent 4 exactly. And I have 0. I can represent it. So don't you see that you got the exact number? It will not give the zeros before. From wherever zeros are there, from there onwards. Because left side zeros makes no sense. Right side zeros make sense, right? It will give like that. 0, 0, 1, 1, 1. In the same fashion, the same thing happens. If you go for 13 also, the same logic happens. 13 hyphen. So can I represent 13 with 126? No. 64? No. Greater. 32? No. 16 is greater? No. 8? Yes. So 13 minus 8 is what? So 5. 5 can I represent with 4? Yes. 1. So what is left? 1. So 2 is greater than that. So 1. So did you see that 1101? You got like 1101. So this can be a big number. This is a small number because of these values. But this is how it is represented. Now, so I'm explaining all operations here itself. So if you want, you have like different kinds of operators here. Just I want to show you. So there are different operations like AND. So ordinary AND we know, right? That is an ordinary AND, right? But this is a binary AND. Logical operation AND is different. Bitwise operation AND is different. So if I execute, you will notice the difference. You need to know in which case we need to use that, in which case we need to use this one. So if you see here, you got the result. So I also told you, if you use logical AND, what will happen here? You get the last non-zero number, right? If all are non-zero, so you get the last value. If there is a 0 anywhere, you get the 0. That is what happens if you do like this, right? So if you do like no, this one, that is the difference. Okay. Now, why when you do, so end of 60 and 13, you get like end of 16 and 13, you got what? This one. AND operation, you got like 2, 12. So OR operation, bitwise OR, you got like 61. So why these are happening, sir? Very simple. How we know the AND operations and OR? In the same fashion, I will do this here. So if I do the AND, logical AND operation, AND means like what? If both are true, end result is true, right? That is what we learn. In the same fashion, if both are 1, result is 1. So else it is 0, 0. At least one of them is 0, right? You have 1, you have a 0. So in that row, so in this column, so one of them is 0, you get 0. One of them is 0, you get 0. Both are ones, true, 1. Both are ones, 1. So both are 0. One of them is 0, 0. So what is 8 plus 2? So we need to add the positions of ones. Where ones are there, those corresponding positions, if you add, you get it. So did you see that you got 8 into 1 and 4 into 1, you got like 12. In the same fashion, if you go for like So pipe symbol, which is like bitwise R. So bitwise R, at least one of them is 1, you get a result 1, right? So both are 0, both are 0, at least one of them is 1, 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 0, one of them is 1. So you have like multiple ones. So you need to add all the numbers wherever the presence of 1 is there, and you get the final result. So that is how it works. So if you see here, so that is how you got like 61. So in the same fashion, I think like you can repeat the remaining values. So similarly, I want to extend one more last point. There is, apart from this, there is something called as left shift and right shift. This is most important. Any number, if you left shift and right shift, what will happen, I will show here. I wrote like this. I have a number called as 10. If I convert to Boolean, I get like 1010. Means remainings are all 0, which are I didn't mention. If I do like a left shift means one position it will shift. Then what is the values? Did you observe? So when you lift shift by one position, the value will be doubled. So instead of 8 plus 4, which is 8 plus 2, which is 10, now it is 16 plus 4, which is 20. In the same fashion, if I go for the one more left shift, every time you do a left shift, the value, see, it is getting doubled. It is getting doubled, right? Whereas similarly, if I go for every time right shift from 160 back, I am doing a right shift. The arrow is pointing to the right side. See here. So it's greater than symbol, only 1. So right shift, 2. That's the difference. Every time doing a right shift. So did you see what happened? It is dividing by 2. That is what we need to know. A left shift by n bits is equivalent to multiplication of power of 2 to the power of that much without overflow, whereas right shift is the reverse of it. So this is all about the bitwise operations that you need to understand. And also the last thing, earlier also I told, and again I want to tell separately as a separate thing. One small thing is identity operations. So what are these identity operations? What all things we will do with this? To understand identity operations, identity, whether equal or not, for that we have a separate function. So till now, you know, 1 equal assignment operator, 2 equals value level equivalence, is a object level equivalence. Just now I told, right? So value means it will tell both value and type are equal or not. Whereas is will check even the address location also. That is the difference. So I just told you already about this one, but just I am enlisting all of that in one place. If you see, when you create two numbers, so both will have the same address locations. One last point I will tell, 0, 5, Python A so and so. Did you see what happened? So when you have two numbers with different values, when you compare, values also will not be equal, address also will not be equal. It makes sense. But for the second value, if you add the same number now, so number 1 is equal to 200. Observe carefully, one interesting point I want to tell here. It is not about the comparison. You already know what is what is equivalence. But here I want to tell one more interesting thing. See, these two numbers were not assigned at one shot. Somewhere it was given, number 2 was given 200. So number 1 was again given 200. So now did you see the address locations? Sir, these two numbers were created differently. We are not assigning from one to another, but still why sir address locations are same? Do you mean that for the values, the address will be the same? Did you understand one interesting point here? So for 200s, if you assign 200 for both, you get the same thing, right? I repeat again with this time with 300s. I'm taking two numbers and I'm assigning same 300 to both. Did you see what happened? Both are equal in terms of value and address location also. Did you observe that the address location is exactly same? If two values are equal, why should the address should be equal? Hope you got this confusion right. Let me try the same thing with the floating point values. Two values are equal. So did you see that address locations are also same? Okay, let me try with string operations. So two values are same. Two values are same. I'm assigning to two different data types, right? Strings I gave. Both are equal in terms of value and address. And did you see that address locations are also same? And now I'm going for one more type of data type called as list. So this is the data structures we will learn in the next class. If you see, so both are equal in terms of the value, but not in terms of the address. Wow. What is this, sir? If I go for like one more last thing before concluding. So if the same values are stored within the flower braces, this is called as a set. If the same values were stored in a flower braces, it's called as a set. For the set also I will ask. Did you see what happened? You got the same answer, but slightly different. If you see here now, you got it. In terms of value, both are equal. Address, both are not equal. Why, sir? For something it is happening like this, for others it's not happening. Means they did some kind of optimization. So in Python, for immutable objects, if you both are assigned the same value, both will refer to the same object location. Means one object will be created only once with some one value. So means if you ask the same value 100 times, 1000 times also, it will not recreate. So that's the reason immutables are very interesting. What are these mutables, immutables? Next class I will tell. For mutables, it's not the other way. Similarly, there is another thing called as dual memory management strategy. Means if the same values if you create in an interactive mode, that is furthermore interesting. I have listed everything here, but for you to show. For values between -5 and 255, 256, when you do an interactive mode on this, it will not create a new object. But if you create outside, it will create a new object. So just walk through it is an assignment. See here. So if both are given the same values, so both address locations will be same in interactive mode. But if you go for 258, it will be false in interactive mode. So why? Because so in interactive mode generally means the Jupyter notebooks and others, where you go with data science or machine learning with large values. So to